How to make an SSD NVMe work. A comprehensive guide to set up an information. An NVMe SSD can deliver blazing fast storage performance when set up correctly, which is why we've put together this comprehensive guide to help you get the most from your investment. We'll cover everything from hardware requirements to installation, configuration, and optimization, as well as how to fix common issues. So you're sure to be able to take advantage of the speeds that these drives are capable of. So let's dive right in. Hardware requirements. Before you can use an SSD, you'll need a few key pieces of hardware, including an NVMe SSD itself, a motherboard with NVMe support, and a CPU chipset that also supports NVMe. There are two main form factors for NVMe drives: M2 and U2 or U3. M.2 drives are much more common and come in a variety of sizes, but the most popular is the 2280, which measures 22 millimeters in width by 80 millimeters in length. U2 drives, on the other hand, are more commonly found in server motherboards and come in sizes such as 230, 340, and 430. If you have an older motherboard or computer, you may need to buy a PCIe adapter card to connect your NVMe drive. These cards typically connect to the PCIe X4 slot on your graphics card and come with an M2 interface for your drive. Once you have all the necessary hardware, it's time to install your SSD. We'll start with the physical installation, followed by BIOS and software setup. Installation. First, power off your computer and unplug it from the wall socket. Next, locate the M2 slot on your motherboard. This can vary depending on the model, so check your motherboard's manual if you're unsure where it is. Some motherboards will have an M2 slot right next to the CPU socket, while others might have it further down near the bottom. Once you locate the M2 slot, remove the M2 heatsink if your motherboard has one. Most newer motherboards have dedicated heat spreaders over the M.2 slot that don't require a heatsink, so you can skip this step if your motherboard looks like this. However, if it doesn't, then remove the existing heatsink before proceeding. Now insert the NVMe SSD at a 30-degree angle into the M2 slot with the notch facing the connectors. Gently push the drive until it clicks into place and is parallel with the slot. Then secure it with the screw provided. You may need to fish the screw out from under the motherboard, if it's not already close by. Finally, replace any heatsinks you removed earlier. Now we can move on to BIOS configuration. First, restart your computer and enter the BIOS or UEFI by pressing the Del or F2 key repeatedly as the screen prompts you. Every manufacturer has their own BIOS layout, so yours may look different than what we have here. Don't worry, the steps remain the same. Navigate to the Settings menu and make sure that NVMe is enabled. It should be automatic by default. If you see a setting called Configure, click it and make sure that PCIe is enabled for the M2 slot. Also, set the boot mode to UEFI instead of Legacy or CSM. This is important because some early versions of Windows prior to Windows 8 used BIOS boot. This was later replaced by UEFI and is required for NVMe drives to work properly. Changing this setting may require you to reboot your system. After making these changes, save them and exit the BIOS. Now we can move on to software setup. Software setup. There are two scenarios to consider. First is when you're installing an SSD in a new system and want to perform a fresh install of your operating system. In this case, you'll need to create a bootable USB drive containing the installation files for Windows or whatever operating system you plan to use. For Windows, you can use the official media creation tool on another computer to download Windows and then burn it to a USB stick. Once you have the bootable USB drive ready, plug it into your system and boot from it. During the operating system installation, select the NVMe drive as the target where you want to install the OS. Then continue with the installation process as normal. In the second scenario, you're adding an NVMe drive to an existing system. First, boot into your current operating system and open the disk management utility. From there, right-click and choose Initialize Disk. Select GPT as the partition style and proceed. This will prepare the disk for use by either creating new partitions or formatting an existing one. If you're installing Linux, use either fdisk or gdisk to create the necessary partitions. Then format the drive with your preferred file system such as NTFS or ext4, and you're all set. Performance optimization. To squeeze every last drop of performance from your NVMe SSD, follow these simple optimization tips. First, make sure AHCI mode is enabled in your BIOS. Older systems might have an option for IDE mode, but you should definitely avoid selecting that. Check your motherboard's manual if you're unsure what setting to choose. Next, update your SSD's firmware to the latest version. You can usually find these updates on the manufacturer's website and run the installer, which will scan your system to find your drive and update it automatically. It's also a good idea to install the latest storage drivers for your setup. For Intel SSDs, download Intel RST. And for AMDs, install AMD Storemi if your NVMe drive meets the requirements. Otherwise, simply update the chipset drivers. These drivers are crucial for getting the most out of your NVMe SSD, as they optimize the communication between the drive and your system. Now, to ensure optimal data management, enable trim on your SSD. This feature flushes metadata about deleted data blocks back to the SSD, allowing it to reclaim space and maintain high performance. To enable trim on Windows, open a command prompt as administrator and type feudal behavior set disobelitanity 0 on Linux. You can add discard to FSTab or enable the FS trim timer service. Finally, check the drive alignment. Modern operating systems typically handle this automatically, but if you suspect issues, use tools such as Crystal Disk Mark or AS SSD Benchmark to check and correct any misalignments. Troubleshooting. If you've completed all the steps above and your NVMe drive still isn't working, try these troubleshooting tips. First, double-check that NVMe is enabled in your BIOS. If you have multiple M2 slots, try switching to a different one if available. Make sure the slot you're using is designed for NVMe drives. Some older boards might have an MDU slot that works with either SATA or NVMe. So check your motherboard's manual to be sure. If you suspect a problem with the M2 slot itself, try testing it in another system if possible, or simply update your motherboard's BIOS to the latest version. This can often resolve issues without you having to do anything else. If none of those options work, try reseating the drive or switch to a different NVMe SSD and see if that one works. If all else fails, contact the manufacturer of your motherboard or SSD for further assistance. Now let's say your SSD is detected but performance is slow. Start by checking if it's running at full PCIe speed. You can check this with a free tool such as Crystal Disk Info, which will show you the link speed between your SSD and your system. If the link speed isn't at its maximum, there could be an issue with the connection or drivers. Try reseating the SSD, updating your motherboard's drivers, and checking for BIOS updates. If none of those options work, try a different SSD and see if that one performs better. If it does, there could be an issue with your specific drive. So contact the manufacturer for further assistance. Also, make sure your SSD isn't throttling due to heat. You can check the temperature with Crystal Disk Info. If it's consistently above 60 degrees Celsius, consider adding a heatsink. SSD NVMe vs SATA. Here's a quick comparison of NVMe SSDs and SATA SSDs to highlight the key differences. Feature NVMe SSD's SATA interface, PCIe SATA Max, speed approximately 3,500 to 7,000 megabytes per second, approximately 550 megabytes per second, latency very low, higher form factor M2, U2 2.5-inch M2 SATA. As you can see, NVMe SSDs offer significantly faster performance and lower latency than SATA SSDs, making them ideal for applications where speed is critical, such as gaming, video editing, and large file transfers. However, SATA SSDs are still a solid choice for less demanding tasks and are typically more affordable. Conclusion. This brings us to the end of our comprehensive guide on how to make an SSD NVMe work. We hope you found this information helpful and that it made the setup process a breeze for you. Remember that proper installation and configuration are key to unlocking the blazing fast speeds that these drives are capable of. So take your time, follow the steps carefully, and you'll be reaping the benefits of improved load times, faster transfer speeds, and overall enhanced productivity in no time. If you enjoyed this video and found it informative, please give it a thumbs up and consider sharing it with your friends and family. And if you have any questions or comments, feel free to drop them below. We love hearing from you guys, and we'll do our best to reply to as many comments as possible. Thanks for watching, and happy computing.